Hi, welcome to today's video about the TOI 700 system. It is a system with 4 planets. 2 of these planets are in the habitable zone of the star. It's a computer render of the TOI 700 from the TESS mission. TOI means Test Object of Interest. This is a red dwarf, also called M star. It is located at a distance of 101 light years. Has 42% of the sun's mass and just 2% of the sun's luminosity. The surface temperature is 3500 Kelvin. That's about 2000 Kelvin lower than the surface temperature of the sun. And about 15% of M stars have an Earth-sized planet in the habitable zone. So it's about the same as with the G stars like the sun. This is an overview of the system TOI 700, and it contains 4 planets all within 0.16 AU. 1 AU is the Earth-Sun distance of 150 million kilometers. 2 of these planets are potentially habitable. The inner 2 planets are not habitable. Closest planet is TOI 700b. It has 1.1 Earth masses and orbital period of 10 days. The TOI 700c is the second planet. It is the most massive planet in the system. That's 7.5 Earth masses. It's a sub-Neptune. It's an orbital period of 16 days. And it's a very good target for future research with the James Webb Space Telescope. This is the outermost planet, TOI 700d. It's at a distance of 0.16 AU. Orbital period is 37 days. It is very likely tidally locked. Its mass is 1.7 Earth masses. Average temperature calculated is -4 degrees Celsius. This was the first Earth-sized planet in the habitable zone that TESS discovered in 2020. This is the other planet, TOI 700e, at 0.13 astronomical units. It was confirmed in January 2023. Its orbital period is 28 days. It is likely also tidally locked. Its mass is about 0.82 times the Earth's mass. And since it's in the habitable zone, this makes liquid water possible. That would be very good for life. And this planet is in a near 4-3 orbital resonance with its neighbor TOI 700d. This is how the planet could look like, TOI 700e. This is sometimes also called eyeball world. There's a permanent day side and a night side. The night side probably contains ice cap. And you can see there's a transition zone here. And since 75% of all stars are M stars, red dwarfs, this could be the most common type of an Earth-like planet. This is another version that's called cold eyeball world. The planet TOI 700d could be such a world because it is located more in the outer habitable zone. And the question is, what happens to the atmosphere? Will the entire atmosphere freeze out or not? And there were computer models, and they show there is enough heat transfer from the day side to the night side by the atmosphere and by ocean streams. And for this, the high heat capacity of water is very helpful. But for planets around M stars, there could be problems for life. These are 2 problems, potential problems. One is the stellar flares. Young M stars go through this phase. This causes atmosphere loss. And the second problem could be star spots. They can last for months, and this causes a luminosity drop. But I think life could adapt to this by, for example, going into hibernation. There are several mechanisms for loss of atmosphere for a planet. This picture is of an image of what has happened to early Mars. There's stellar wind evaporation and photoevaporation. And there's a limit 0.1 AU. If a planet is closer to 0.1 AU to its star, then it could lose completely entire atmosphere. This is a picture of CubeSat. It's 10 centimeter mini satellites. There are over 1,600 in orbit. This CubeSat will be used for measurements of the flares of M-stars, red dwarfs. And M-stars, during the first 8 to 10 billion years of their life, they make these flares. This is one big difference of M-stars compared to sun-like stars, the G-stars. M-stars have a much longer main sequence lifetime, can go to the trillions. In this diagram, this x-axis is mass in the solar masses, and y-axis is lifetime in the main sequence. And you can see the least massive, the lightest M-stars, the red dwarfs, have the longest lifetime because their fusion zone is the smallest. They use the hydrogen very slowly. And the lower mass limit for M-stars is about 8% the mass of the Sun. That's about 80 Jupiter masses. And below 80 Jupiter masses, you have brown dwarfs. And for comparison, the Sun, its main sequence lifetime is about 10 billion years. Then it will become a red giant. Then it will lose about half its material to space and will become a white dwarf. It's another artist image of the planet TOI 700e with potential exomoons. You can see 2 exomoons. Since it's probably tidally locked, its rotation speed is very slow, which will give it a weaker magnetic field compared to Earth. Here you can see the ice cap on the night side. And since the planets are packed closely together, there will be strong tidal forces between the planets. This is how an eternal sunset over the ocean of the tidally locked TOI 700e could look like. This is how the transition zone could look like. There was a test. Scientists tested photosynthesis of cyanobacteria under conditions of M-star light. 2 species were tested. One, the Nishith, which grow using visible photons. They grew slowly. And the second species, Chloroglopsis, Ichi, they are capable of photoacclimation of far red light, and they could also grow under these circumstances. This is another picture of the red dwarf TOI 700 with 3 of its planets. This is the Julien Chinese Survey Space Telescope. It has a 2-diameter primary mirror. This will give it a wide field of view. This telescope will be launched in the year 2024. Then it will be able to image 40% of the sky within 10 years. It's another very impressive project. That's the Giant Magellan Telescope in the Atacama Desert in Chile. It's a telescope of 30-meter class. It will be used for the search of Earth-like planets. It has 4 times the resolution of the James Webb Space Telescope. It will be completed in the late 2020s. It's a $2 billion project. For example, 2,100 tons steel were used to build this telescope, and it will probably be in service for 50 years. And that was today's video about the fascinating planet TOI 700e in the habitable zone of a red dwarf. You can check out the links in the description field. Thank you for watching. Have a nice day. Bye-bye.